Welcome back to Advent of Code. We just finished Advent of Code 2015 and now we're going to go to Advent of Code 2016. Actually, I think here's a button where I can see all the years, and we see we got all the stars for 2015, and our total star count is the same. So now we'll jump into 2016. Day 1. No time for a taxi cab. Santa's sleigh uses a very high precision clock to guide its movements, and the clock's oscillator is regulated by stars. Unfortunately, the stars have been stolen by the Easter Bunny. To save Christmas, Santa needs you to retrieve all 50 stars by December 25th. Collect stars by solving puzzles. 2 puzzles will be made available on each day in the Advent calendar. The second puzzle is unlocked when you complete the first. Each puzzle grants 1 star. Good luck. You're airdropped near Easter Bunny headquarters in a city somewhere. Near, unfortunately, is as close as you can get. The instructions on the Easter Bunny recruiting document the elves intercepted start here, and nobody had time to work them out further. The document indicates that you should start at the given coordinates where you just landed and face north. Then follow the provided sequence, either turn left or turn right 90 degrees. Then walk forward the given number of blocks, ending at a new intersection. There's no time to follow such ridiculous instructions on foot, though, so you take a moment and work out the destination, given that you can only walk on the street grid of the city. How far is the shortest path to the destination? So we have taxi cab geometry or Manhattan distance, where we can only walk in grid. So if we want to go across, then it's distance of 2. How far is the shortest destination? For example, following R2, L3 leaves you 2 blocks east and 3 blocks north, or 5 blocks away. R2, R2, R2 leaves you 2 blocks due south of your starting position, which is 2 blocks away. And this one leaves you 12 blocks away. How many blocks is it to Easter Bunny HQ? So this is our input. Let's do the example inputs. And we have a string with the inputs. We need to parse it. Actually, we can pop this into our input, and then we want to read 1 line, which we split at comma and space, I guess. For each instruction, we always have a letter or a direction, car, and a distance. Let's see if there's the distances are only, oh no, here's one, L 194. So we just take the rest. Substring 1 to length, get an int, and then so we turn left, then we walk the steps. And where do you start? Face north. Okay, var facing north. How can we do this? North could be 0. And then the direction is L, we do -1. Else it's right. It's only R and L, right? Facing +1. And then we want to like stay within 0 to 4. And then we know that we have to like decode this for ourselves. North. 1 is east, 2 is south, 3 is west. So we do mod 4. So we have 0, 1, 2, and 3. Then we walk in the direction there. The direction is kind of a grid. So let's say we start at a I'd like to have my pair class. X, Y, position of 0, 0, and then we can walk around. North means up. Can I do this with the plus? Weird. Or we can just say add p.add. Or how does it work? Let's see. We want to get this dot x. We want to get a new p with this dot x, other dot x, and this dot y plus other dot y. Yeah. So if we go north, and the other thing we could do is get. Yeah, let's just follow through with this position. So now we go east, which means we go one step to the right. Now we go south, go one step down, and west. We go one step to the left. And actually, we don't want to go one step, we want to go distance amount of steps. I wonder if I can do this. And then we just have to print the position, and we can easily get the distance from the starting point by just adding the two coordinates. 2 blocks east and 3 blocks north. Minus is north, or like minus is higher than 0, so it's north. And 2 is east. Or positive on the second axis is east. Okay, so then we just have to get this plus this, and then we should get the Manhattan distance. 5. Let's try this one. 2 blocks away, and then we want 12 for this instruction. Yeah. Okay. Then we can go to puzzle input. Oops. And we get 410. See? Too high, interesting. What's the output? Interesting. Okay, let's see. Facing and one thing that was different about the input than the example is this big step here. Here, this one. Curious if this would work. Actually. So what does it do? 140. Go right, 1, go left, which is then north again, 140, 194. That looks right. We only have left and right. Print the instruction. Go turn right and then go 4. Then we're facing 1 is right. And we went 4. Then you turn right and go 4, which goes south 4. Left 1. Ooh, yeah, we turn back to face direction 1. Let's see what happens. Ah, okay. So if we're at 0, then we suddenly go -1. Which I don't think we do anything then. I can do this actually. Invalid direct facing. Facing. That's the issue. Error. Okay, so we can just do it like this maybe. To be sure that we always stay, we don't go negative. Kind of on mod form, but without going negative. So we have to adjust first. And then we don't see our invalid direction, and we have a different result. Let's check this. And that's it. Okay, let's go through it. So we pick our 4 directions, 0, 1, 2, and 3. And we start facing into 0, which is north. And then if we see an L, we go -1 modulo 4, which is 3. So we turn left, and then we turn west. If we see an R, we go from north, we go +1, which is 1, and then we turn east. So this way we can navigate where we're looking. And then after we, with each instruction, changed our direction where we're looking, we can walk the amount of steps. So we first have to start at some position, for example 0, 0 on a grid. And then we just walk into the distance, and the distance is then applied into the direction that we're facing. So if we're walking north, we walk negative the distance in the x-axis. So this is kind of arbitrary. We just have to decide which distance we want on which axis, and then we have to follow through. So then east is positive on the y-axis, south is positive on the x-axis, and west is negative on the y-axis. Then, yeah, it's good to check that we don't have the extra case where we had the little bug, and then at the end we have a final position. So for example here, 50, 85 and 61. And to get the Manhattan distance from 0, 0 to 85, 61, we just have to add the 2 numbers regardless of their sign. So that's why I take the absolute value, which just gives me, if the number is negative, it gives me the positive number, and if it's positive, it gives me the positive number. That's how you can get this grid distance. Taxi cab geometry. Because if you go negative, it doesn't matter. You just need to count into the 2 axes how far you are away. Okay, part 2. Then you notice the instructions continue on the back of the recruiting document. Easter Bunny HQ is actually at the first location you visit twice. For example, if your instructions are this one, the first location you visit twice is 4 blocks away due east. How many blocks away is the first location you visit twice? Okay, so now we have to save all the visited positions. In a list. So I mean, we can start with our starting position, right? And then we can visit a position and add current position. And then if we do it like this: if position in visited position found it, or we can have another list: double visited at this, and then we always add, and we can just finish it. Then we can check the first double visited position. Which is our result. And then we go and calculate the distance for that one. So we just add, we always add the new position into visited. The first one we visit twice is the one that we're looking for. The problem, I think, now is that we are only calculating, like we're jumping the whole length of the distance, and that's the new position. And we should get all the intermediate positions as well. So we can do beat distance times this, and we only go 1. And we always add all the intermediate positions. Yeah, so now we have that 4 block east kind of solution here. So we have to distance times, so if distance is 8, we go 8 times 1 step into the direction that we want to go to, instead of going 8 steps at once, for example. So we go back to our input, check the first distance, calculate the distance, and that's it. That's it for day 1. Already harder than day 1 of 2015. So that's it for today. Thanks. See you next time.